Hello, students. So I'm going to have a tutoring class here. And this is our Smart Kids Learning Center tutoring class. And for the phone number 647-778-8725 for online class. And please book a first free online class. And the class we are tutoring is advanced function and calculus. In English, today, I'm going to tutoring you the grade 12 advanced function. And I'm going to show you the book. And after the class, and please subscribe. So the book I'm going to teach is Advanced Function Grade 12. And we're going to do it from the beginning. So chapter 1, excuse me. For chapter 1, unit 1.1, page 7. So I'm going to explain to you the concept. And when you know the concept well and the example well, then you have the skill. No need to be skillful. You have the skill to solve any problem easily. So what is a polynomial function? So it is the exponent whole number and positive. 1, 2, all the variables stay for the same letter. Only 2 elements to make it qualify for polynomial function. Let's do example 1. So on page 7. So to make adjustment, if these are polynomial function, let's do A. So g and x is equal sine x. So sine x is a trigonometry function. So therefore the answer is NO, no polynomial function. How about B? F and x equal to x exponent 4. The exponent is a whole number and positive integer. So therefore it fits the criteria. And yes, polynomial function. And number C. So y equal x exponent 3 minus 5x exponent 2 is 6x exponent 1 minus a. So all the exponent are whole number and positive integer. And all the variables stay the same letter. Yes, it's a polynomial function. For D, g and x equals 3 exponent x. And x exponent is not the number, it's a variable. So therefore, NO, not a polynomial function. And just simple like that to make the adjustment pretty easy once you understand it. So in the next one we are going to do is the example 1. Oh, excuse me, example 2 on page 8. So page 8 is asking you the example 2. Number 1, find domain and range. Number 2, describe the end behavior. Number 3, find the symmetry line. So A is y equal negative x exponent 1. So it's a polynomial. So we're going to plot this linear equation. To plot it, we're going to get x-intercept and y-intercept is at the origin. And we're going to get 1 point. When x equals 1, y is negative 1. So we take 2 points, plot the line. And from the graph, you can see the positive y is going to be negative infinity x. The negative y stay negative here, is going to be positive x infinity. So therefore, there's no restriction for a linear, or furthermore, for any odd degree polynomial function. So there's no restriction for both domain and range. We only need to state they are element of real numbers. Now we're going to define the end behavior. So it's involved two quadrants, 4 and 2. Then we're going to write Q4 to Q2. Always is write the end, this end behavior stays for first and then go to the beginning. So, and then how about the behavior? As I already explained to you. So as X approach to a negative infinitive and Y is positive, Y approach to positive infinitive, the other way. So as X approach to positive infinitive and Y is negative. So therefore Y approach to negative infinitive. So, and that's the end behavior. And we're going to find the origin. The origin is here. The symmetry is at the origin. So therefore, all the odd degree symmetry at the origin is a rotational symmetry. So at the odd degree function has a point origin symmetry. And that's example 1. So now we are going to do example 2. So example 2 is state for B. So Y equal 0.5x is only 2. So we plot the graph. First, we're going to find the vertex C. The vertex C is at the origin. I'm going to explain the graph. So you see as X approach to positive infinitive, Y is positive. As X approach to negative infinitive, Y also negative, Y also positive. So this is an even degree. So, and then we're going to write they involve in a quadrant from 2 to a 1. So let's write the explanation. So for domain. So D. So X is element of real numbers. It has no restriction. You see the arrow grow infinitively. So how about range? So Y is element of real numbers such as a condition. So Y is going to be larger or equal 0. So it has a minimum, so restricted. It's a positive function open up. So therefore Y is larger or equal. So, and then we are going to write the end behavior. So it's going to be from the Q2 to Q1. And you're going to write S, X approach to positive infinitive. So, and then Y approach to positive infinitive. So as X approach to negative infinitive and Y approach to also positive infinitive, and that's the end behavior. So, and you're going to write what kind of symmetry. So you're going to write, so symmetry at y-intercept, y-axis. So it's an even degree. Even degree, always symmetry in a y-axis. So now we're done. So how about the C? So C is going to be, so I'm going to write here. So, and you see it in a full page. So it's a Q-bar function. So it's going to be Y equal 4x exponent 3. So it's a symmetry at the origin. So we draw the first, the beginning, at the end. So we're going to answer the question. As you know, the odd degree, it has no restriction for domain and the range. And also symmetry at the origin. And also as X approach to negative infinitive to the origin, and this one, what happened? And Y, you see the graph, Y also that approach to negative infinitive. as x approach to positive infinitive in the first quadrant, y is positive. So the end behavior is different with a linear. So you're going to write like domain. Yeah, I already explained to you. So I think it's you already know. So I write it quickly. Odd degree, again, no restriction. So, and then from Q3 to Q1. So, and then symmetry. At the origin. So that's how you explain it. So we finished the example 2. So now I'm going to do example 3. So what is example 3? Example 3 on page 9. So still for chapter 1 and unit 1.1. So it's asking you describe the end behavior of the power function. So we're going to do the first one. So for A, so y equal to x. So to find the end behavior, so I'm going to just draw a graph here, smaller. So it's a positive function. So you're going to write end behavior just from the quadrant 3rd to quadrant 1. So what is the reason? So the reason is the odd degree. We just write odd. So now for a B, so B is going to be y equal negative 2 over 5x exponent 9. It's also an odd degree. So 1 and 9. So I'm going to plot it here. Yeah, you can make the graph. And you can make it, or you can make it more complicated, like as many curves as you want. Just curve the lines, but they still, the principle is quadrant 2nd to a 4. So therefore, we explain the behavior. So it's called 4 to core 2. And also it's the odd degree. So that's for B. So it's C. So we're going to have a y equal 5x exponent 6. So this is the even degree. So we're going to plot it. So it's a positive leading. So open up. So that's the graph. Then we are going to make it for quadrant and behavior Q2 to Q1. So, and then what is the symmetry? So it's symmetry at the origin, at the y-axis. So it didn't ask you symmetry. It's only asking you, this is a positive leading. In even exponent. So now we explain it to you all the even exponent in the next video. Bye-bye.